Ito, si Kalon. Wabi.
Good afternoon, all. Yes, guys, can anyone please confirm me? Am I audible? Miss Pratyusha, can you please confirm? Okay. Yes, guys. And we didn't have session yesterday, so don't worry. We had some technical issue from our end, so hence the class was cancelled. Yes, guys. Hope everyone had the lunch. Yes. Okay. Cool. Hello, guys. No, this is for AI and then ML, not merge stack and all. Sunny, is this your first class? Yes. Good afternoon, guys. Okay. So, in the previous session, we learned about unsupervised learning, right? And in that, we learned about clustering. And we finally ended up with k-means clustering, right? So, in this class, we're going to learn about the remaining unsupervised learning concepts. Okay, let's wait for a couple of more minutes and then we can start off with our session. Don't need much because I'll be covering the unsupervised and then some more about parameters and all, like hyperparameters. So, and also we're going to have a quiz. So after this first, like one break, first break. Yes, guys. And if you have any doubts from the previous class, you can ask me now. Yes, Apurva, if you have your college starting, you will be getting the recorded sessions. Don't worry. Yes, sir. Yes, guys. So let me share my screen and confirm me if my screen is visible. Yes, guys. I hope my screen is visible to all, right? Right? Okay. So, yes, guys. Any idea about what is this hierarchical clustering? So first thing, clustering, it's an unsupervised learning where you will not have, where you will not be training on your label data, meaning you're not having any kind of targets or labels, isn't it? So you will be finding the patterns even from your input data itself. Okay. So we learned about k-means clustering in the previous class. Now we'll directly dig into hierarchical clustering. So what do you understand by the term hierarchical? Yes, guys. So what do you understand by this term hierarchical? Yes, guys. Any responses related to each other? Order tree-like structure, dividing like specific parts, branches. Yes. So most of you have correct said the correct answers. So it's like a tree-like structure where you have some flow. Okay. Initially, you might have some cluster. From that cluster, you'll be dividing into multiple clusters, and you'll be dividing into small clusters, right? So to understand this hierarchical clustering, I could bring about a real life example. Let's consider everybody would have everybody has your laptop, right? So in your file directory, like your file manager, you'll be creating your what is it, documents, right? So you can create a folder name called as, what do you say, like have, you can create a folder name, be it anything, okay, like your name, okay. First folder name can be your name, followed by, right, what is that, be inside that your name folder you will have multiple other folders, like you can have you can consider school or work or any personal thing, okay. So initially you have one folder called with your name. Next you have a folder under this your name that you can have subfolders you can consider, right? You can have school, work, or any personal. Okay, and if chosen the school folder, you might have another multiple folders. So you can have what you can have. You can have your subjects as maths, science, history, or anything, isn't it? And if you deep down, if you go deep down as well, and if you consider only your math as a subject, you can have multiple subfolders like algebra, geometry, and all other stuffs, isn't it? So if you see, what are you trying to do? You're trying to literally group based on some patterns, right? So here, what are you trying to do? Here is you're trying to build some kind of nested folders inside of one particular folder, isn't it? Or we can take an example of, let's take another example of fruits. Okay, so initially you might have what you can consider. Let's consider you have like apples, oranges. We can have mixture of both apples and like fruits and vegetables. Okay, so it can be apples, orange, bananas, and grapes, and some vegetables like carrot and potatoes. Okay, so here what can we do? Here we have a mixture of both fruits and vegetables, right? Now if you want to partition them, or if you want to cluster them, or if you want to group them, so first thing is what you can group it under. First thing is fruits and vegetables, right? So right below the fruits cluster, you will have apple, oranges, banana, and then grapes, right? Now next to the vegetables cluster, you will have carrots and potatoes. Now right below this fruits itself, you have apples and oranges and bananas, right? So here also you can make this fruits and vegetables can be in the first level. That can be considered as a first cluster. Now if you go down to the second level, or you can consider level 2, now you can have another two groups called as citrus fruits and non-citrus fruits, right below the fruits group itself, fruit cluster itself. Okay, so if you have citrus as your folder name, you can have oranges, right? And in case of non-citrus, you can have apples, bananas, and then grapes, isn't it? It's clear. So what are you trying to say? You're trying to see first you're trying to cluster based on some similar characteristics, isn't it? So that is what we're going to do in our hierarchical clustering. So what we are going to do, we are going to create what you can say a cluster. So from the cluster, you can have multiple small clusters. Is it clear? So everything happens considering a similar characteristics. Is it clear? Now, what does our PPT shows? So first one is it is a cluster of, or is a hierarchy of clusters, right? So in our example itself, to show this hierarchy of clusters, we will be using a visual form called as this dendrogram. Okay, so what is this like? It is like a tree-like structure, right? So initially you can consider as your name. Next you will have fruits and vegetables, right? So right below the fruits you will have citrus and the non-citrus, and here as well you can have exotic vegetables and the normal vegetables. Is it clear? So what are you trying to see? You're trying to cluster, or you're trying to group your data depending on a similar characteristics. Is it clear? So here also you're not specifying what is it, how many clusters you needed. Depending on the data that you have, you will be finding some patterns. Likewise, so initially I had the data as like what, apples, bananas, oranges, and some fruits like potatoes and then carrots, right? So this was your data, but after that you were able to find some of the other patterns, right? Initially fruits and vegetables, next you followed by citrus and non-citrus fruits, isn't it? So these are the ways if you want to cluster your data, you will be using this hierarchical clustering. Is it clear? Now there are two ways. Okay, one is agglomerative, that is bottom up, and the other one is divisive. So to make you understand this, I can take an example of this is like you're going to start it from the base, that is the leaf node. So whatever you have it on the downside, right? So you're going to group this and then find one cluster, then you're going to group another one. These are one clusters, right? So you're going to come from the down. Okay, that is bottom up. So it can also be called as agglomerative approach. Okay, so what, let's take an example of to understand this, you can consider. So initially when you have got into your college or school or something, you will be an individual route, right? Isn't it? So after some days, what you will be doing, you will be having friends with your common mindset, like people who are interested in sports. You will be having a friendship with them, right? Like initially you will, at the start of the first day, you will not have any friends, isn't it? But after a couple of days you will be having some friendships. How will that happen? Or they might have the same subject, like say same mindset, or like a student who's going to go sports or any extracurricular activities. If they have some, if you have students with them, you will be able to make some connections, isn't it? So it is like grouping your friendship, isn't it? So initially you didn't even have anything, and at the last you will have so many friends, isn't it? So as and when time goes, you will be having your first, initially only you will be there, Next, a couple of 3 friends will be there. A team of 3 will be there. Next, the whole class will get to know your group. Next, your whole college, isn't it? So here, what we can do is here we are literally trying to group from the initial data points itself. Is it clear? Now, if we come to this, we can consider this bottom up as we are going to, what do you say, group, individual, okay, individual data points to one cluster. Is it clear? So we are going to start from the individual data point that we are going to have and then find the cluster. Is it clear? But coming to the top down. So what is the top down? Top down is nothing but you're going to divide or you're going to split it from the top itself. Is it clear? So you can consider an example of what we can consider. So initially you might have, let's take the college example itself. Initially you can consider your classroom as your cluster. Okay. Then you will be dividing your classroom based on girls and then boys. Okay. Next, in terms of boys itself, you might have students who might like you might differ students where one student might like a group of students might like sports, the other students might not like for sports. Okay. So here what are we trying to see? First, you're having the biggest cluster, then you're grouping them depending on the differences you make. Okay, that is what we're going to do in divisive. Is it clear? So in case of bottom up, we're going to what do you say? We're going to gather, okay, to make a one cluster. But in case of divisive, we are going to split, meaning based on the differences, we're going to split them. Is it clear? Now we have this dendrogram. So what is it? Dendrograms? This is nothing but how you will be able to visually show this hierarchical clustering. Okay. So if you're going to consider, let's start from the base. So if you're going to consider this bottom up, okay, that is argumentative. That is initially you will be having this A and B. So based on this, you will be clustering them. Is it clear? Next, let's start off with this one itself. We have this E and F, right? So this might have some similar characteristics. So hence they are grouped under one cluster. Next, this is one cluster. Next we have this one. So they might have some similar characteristics. Then these two can also be clustered into one thing. So here, if you're going to go from the base, that is from your leaf node, starting from leaf node and then it with cluster, then it is called as bottom up. And now if you're going to come from up, okay, that is called as divisive. Is it clear? Now the height of the merge point indicates the dissimilarity. So what is this? So height, whatever the height that is there, right? It is going to tell you the difference between each clusters. Is it clear? But the next one, what is the nearest, the closest one that you have, right? That shows the closeness. Okay, that is the similar characteristics between the data points. Okay, so initially, if you're going to consider this is your data. Okay, you have a data of like A, B, C, D, E, F, and scattered at different places. Now you want to cluster them. Okay, now you want to group them. So how are you going to group? Since these are very close to each other, they can be clustered under one cluster. And C1. Next, as this is very closer to this, like EF cluster is very closer to D is right. So this can be called as another cluster. Okay. Now, since these three are one, you can consider, and then it is very close to C, right? Rather than A and B. So this can be considered as a one, what is that, cluster. So that is what we have shown here. So EF can be clustered at one. Then which is the next closest data point that we have? It is D, right? So this can be, so what we are trying to do is we are trying to find the distance. So which is the closest one? That data point will be put into that particular cluster. Is it clear? I hope it's clear, right? Have any questions? Is it clear, guys? So we have this first one is algorithm, that is bottom up. So mainly it's like hierarchical is nothing but you're going to cluster or you're going to group, you're going to find some patterns depending on some similar characteristics. So similar characteristics can have bottom up. So what is that? Initially you're going to start from the scratch. So what is the leaf node? What are the data point that you have, individual data point that you have? Based on some similar characteristics, you will be grouping them. It's nothing but clustering. Okay. But coming to divisive means you have to divide. So how will you divide? Based on the differences. Okay. So initially you will have, you can consider the whole pizza. Okay. So in case of divisive, what is that? If you will, let's consider you have one big whole pizza. Okay. Then if you're going to slice it into 4. Okay. So that is called as, first initially you might slice into 2, next you're going to slice into 4 pieces, then you're going to slice into 8 pieces, isn't it? So in this way, depending on the differences here, please make a note. In case of divisive, you will be finding the differences between the data points, while in case of algorithm or bottom up, you're going to see the closeness depending on the common or similar features. Is it clear? Yes, is it right? Is Devendra? Did you get it now? So hierarchical is nothing but you will be storing or you will be clustering, you will be finding some patterns in a tree-like structure. Okay. To make you understand even more simple, you can consider your file directory in your laptop. So initially you will have one big folder, right? Then inside that you have multiple subfolders, and each of those subfolders will have small Inca or small folders, right? So here, what are you trying to say? You're trying to group or you're trying to cluster, okay, a given data point. Is it clear, guys? Please draw the diagram as well, and if you're not able to understand, just let me know. Or we can also take an example of library, okay, for this divisor. So initially you can consider your library, college library you have, right? So that can be called as your last cluster you have. Next, right below this library, you will have fiction and non-fiction, right? Isn't it? Next, right under the fiction, you might have mystery or like fantasies or any science fiction book. Next, coming to non-fiction, you will have perhaps you'll have history or any kind of science related books. So here, what are you trying to say? You're trying to literally split, or you're literally trying to divide whatever the data that you have based on some differences between your data points. Is it clear? That is what you're going to do it in divisive. I hope it's clear, right? Can you move to the next slide? Yeah. So let's go to the next slide. So next we have the concept called as dimensionality reduction. So dimensionality reduction is nothing but you will be you will be removing a particular feature. Okay. Let's consider you might have hundreds of features. So in that you might not have, since you want to have 100 features, it doesn't mean that you're going to have an accurate data. Okay. You might have some inconsistent data or you might have some duplicate data. So it is better to remove those, right? Because it is better to say that if you have a lot of data, it is very easy for you to analyze the data. But too much data is can also be problematic. Okay. I hope it's clear now, guys. Now, to understand this, let's consider if you want someone to describe a particular car. Okay, so he would literally start off with what does it make? Is it a Toyota or Honda, or what is its model? Is it Camry or any kind of Civic, or what is its engine size? What is its fuel efficiency? How many number of doors does this car have? What is the seating capacity? What is the top speed? Right, price, everything. So these are all the dimensions that you can consider. So these are dimension nothing but each characteristics of the input variables that you can consider. So depending on that, you will be able to get some insights, right? So if you have these features which are effective, okay, given any particular two features, if you're able to get some, it is better to have 20 dimensions, meaning I would say, rather than having, let's consider this example. Let's consider you are trying to cook something. Okay, if you have only 10 ingredients to cook a particular dish, it would be very easy, because starting from cutting and then preparing it, doing it all, cleaning it all, it is very, very easy. But what if you have 100 ingredients to particularly cook a particular dish? So it might take a lot of time, right? Isn't it? So that is what we're going to do it in dimensional reduction. So what we're going to do is we're going to reduce our dimensions. So dimension nothing but the features that you can consider, or the number of columns, or number of the characteristics that you have considered from your data. Okay, so it is better to remove a particular feature. Okay, why do we have to do that? so that you can, what do you say, you can literally not care much about the inconsistent data or duplicate data, meaning the columns or the features that doesn't have more impact or doesn't even have a single point of effect, it is better to remove it, right? So in that case, given, let's consider you have some application, okay, like social media application, like let's consider this what is that, Amazon, okay. And this, if you're going to collect the data about regarding everything from your customers, okay, so initially it would be great, but what if we have different, like 500 to 1000 different pieces of information dimensions? So it would be very difficult, right? So what you're trying to do, you are going to find some feature, you're going to find that particular feature that has the best impact, isn't it? So here as well, like whatever the data that we are having, it is all, what is that, it is like a structured format, but in reality we will not have any kind of structured data. It's clear. So given the structured data, we have to make sure what are the column names or what are the dimensions or the characteristics that we have to consider, so that we will be able to, what is it, take some decisions. Is it clear? So it doesn't mean that just because you're going to remove or reduce a particular feature, let's consider this. So everybody would have definitely had this read a storybook, right? So at the end of that, the back of the book, you will have a summary, isn't it? So what does that show? Does it going to what is that? Not give you? It is to give you an over idea of all of what is that whole story is about, right? Isn't it? So here as well, what we're going to do is in dimensional reduction, we are going to remove a particular feature. Okay, meaning what are the things that you're going to have? We are going to have the much impact one. Okay, which has most important features that for our model to be, for our decision to be taken, that will be considered. Okay. So when removing a particular, it doesn't mean that you're going to choose random features to remove it. Okay, you're going to choose only those that doesn't have much impact. Okay, it is similar to, what do you say, in the story? What is that in the storybook as well? So at the end of the back of the book, you will have some a summary, right? So what does that show? It is a concise way of you not having every phrases or repeated words, or your that unique word being repeated multiple times. You'll not be using it, right? But you will be giving a concise summary, isn't it? That will have the same impact if you're going to study the whole thing. Is it clear? So in the similar way, in dimensional direction also, we are going to retain. Okay, so retain means what? We are going to have the most important features for our model training. Okay, which will have the maximum impact. Okay. Is it clear? It would be better if you have like 10 record, what is it, 10 features. Okay, you will be able to remove a particular 2 to 3 depending on your effect on your data. Okay, but what if you have hundreds or thousands of features? It will be very difficult, right? It is similar to what a particular user in Amazon or Flipkart gives it. So based on the reviews that a customer gives, he might give about his own experiences or no. So if the company has analyzed all these things, it may take a lot of time, right? So the company will only choose a repetitive one or the most effective feedback the customer gives. Okay, based on that, he will be able to take up some call, isn't it? So why do we have to do that? It is to, as scientists say, it is the curse of dimensionality. That is what I was saying. So if you have too many features, meaning let's consider we have this iris data set, right? Since we had only 4 columns, you were able to get some idea about the classes of iris flower, isn't it? But what if we had tens or hundreds of features? It would be very difficult for you to get some conclusion, right? Isn't it? So if you have more features, it shows that, yes. So this will be done in the feature engineering and in the decision tree. You don't have to worry about it. We have so many algorithms to look at what are the features that we can be considered for our model. Okay. Is it clear? And I was also talking about this one, right? This one, the faster training. So what is this faster training? It is similar to if you have 10 ingredients to make a dish, it would be very quick and then efficient, isn't it? But what if you have hundreds of ingredients to prepare one dish or a particular 2 or 3 dishes? It might take a lot of time, right? Or you can take, let's consider a plan to go for any trip. Okay, you will only plan about like 3 to 4 pairs of your clothes, right? Are you going to pack all your closet or your whole cupboard? No, right? Isn't it? If you're going to do that, it would be very difficult for you to choose the correct one or the best one. But if you have less number of features which has much impact, that is what is going to help us in our model training. Is clear? Next, data becomes plottable. Meaning what? If humans can analyze, what do you say, a 2D and then 3D, right? But what if we have multiple dimensions? If you have like 4D and all, it would be very difficult for you to understand, right? So these dimensions can also be plotted in this 2 and then 3D. And moreover, what is the main advantage of using this dimension is to reduce the noise. So what does this reduce the noise? It is to filter, it is to remove the irrelevant. Okay, let's consider you have this the dating app. Okay, in the dating app as well, if you're going to select all the filters, will you be able to see any particular what is that any person coming into your search? No, right? If you're going to have less number of filters or if you're going to have less number of features selected, you will be having more number of people, isn't it? It has applied the same way here. So you have to remove a particular you have to remove some of the irrelevant or inconsistent column that you have or inconsistent features that you have in your data. Okay, so dimensions are nothing but you can consider the characteristics in your data or features or input variables that you have. Okay, next comes the principal component analysis. So what is this principal component analysis? It is nothing but it is also used for this dimensionality reduction itself. So it is to say, so initially you might have, let's consider you might have 5 columns. Okay, and that 5 columns you might also want to bring about a new column. Okay, so let's consider, are anyone fitness freak from our group? Is anyone a fitness freak? You can take his name for example. Yes, Jay. So Arpita. Okay, let's consider Arpita or any Jay. Okay, so Jay, let's consider you're a fitness freak. Okay, initially you might have what is that, as an Excel sheet or a table. In that you might have, let's consider you might have your height, weight, your body, your fat percentage, and the number of hours you put to for exercise per week. Okay, in a week, how many hours would you spend for exercising, and your diet quality score. Okay, most important is you can do a lot of hard workouts, but the last thing that comes to you is to maintaining your diet, right? And you can consider the number of push-ups that you can do and the time that you took to run a kilometer. Okay, it also does apply, right? So let's consider these are the things. What are those? You can consider height, weight, number of push-ups, number of hours he spent to work out, okay, and the time he has taken to run a kilometer. So in this, like some or the other thing are related to each other, right? Correlated. Now let's consider you have this height, weight, and then push-ups. Okay, this you can be calling it into one axis. Okay, so here we have this diagram, right? Where is this diagram? Next PPTs. Yeah, let's consider you have this X and Y is there, right? So what are the data points that you have? You have all been mentioned it here in this graph. So now you're literally able to draw one line. So what does this do? This is going to, what is it? What do you say? Capture all the variances. What are these variances? Variance are nothing but how much is your data spread out. Okay, कहाँ तक आपका data spread हुआ है. So इसमें हमको we will be able to get to know, right? So we have took the example, right? So if you want to consider this, so whatever that we have, height, weight, body percentage, number of hours he spent to work, that can all be spread out, mentioned into the chart. Okay, now we want to create a new column that we can consider. Okay, so that new feature can be, let's consider the two features can be number of push-ups and the time he has taken to run a kilometer. Okay, if you're going to consider these two, okay, we can bring about a new column called as this endurance, right? Isn't it? Yes or no? So this endurance is nothing but by drawing this PCA line, that is principal component analysis. So what is this going to do? It is going to find a new, what is that, axis. Okay, in a meaning what? It is going to analyze your data, or it is going to capture your most meaningful variation in your data. आपको डेटा तो स्प्रेड आउट हुआ है, सो इसमें क्या इसका लाइक इसमें क्या फीचर हो है, उसमें ज्यादा वेरिएशन दिख रहा है, ज्यादा इफेक्ट है. सो उसको हम क्या कर सकते हैं? वी कैन लिटरली ड्रॉ स्ट्रेट लाइन टू अंडरस्टैंड दैट. Okay, so next, this is done. Okay, meaning what? You will be able to find the most, what is that, spread out data, isn't it? Is it clear or not? Now you're also going to find another PCA, that is also a straight line. Okay, so meaning what? You will be finding a linear relationship between your, meaning you will be able to what do you say, see how much is your data spread out. Okay, so variance is nothing but how much is the scatteredness given your data. Okay, so यहाँ diagram में क्या दिख रहा है हमको? तो the first, whatever the data point that we have, we were able to draw one PC1, that is principal component analysis. So what does this show? This shows that this line has maximum variance, isn't it? This is the whole variance. Now you're going to draw another what is that, axis. Okay, another linear equation. What does this do? This will be perpendicular to this one, PC1 itself. Now it will be able to find some what is that, patterns. Okay, what does it do? It is able to see only this much of variance, right? Meaning this much, isn't it? So this PC1 has maximum variance, meaning you can bring about some new feature or new axis by drawing the straight line. And this one also, as when, and you can see the PC1, the first principal component axis, will have the maximum effect, or will have the maximum variance even the data. Okay, the second might have less than the first one. So it similarly goes on. Okay, now if you're going to consider, this is what I was talking about. Let's consider you have two variables initially. Okay, you have plotted them in the graph. So the variable 1, this is variable 2. Now if you want to find some what is it, variance, or if you want to find some new data, okay, new line. Okay, meaning new line means what? You will be finding what is that, linear relationship, right? If one goes up, the other one also goes up, and if one goes down, the other one also goes down. So here you will be able to see some covariance as well. Meaning, given you can have this, there is two difference between variance and then covariance. So variance is nothing but how much of your data is scattered or spread out. Next, we have this covariance. What does this covariance represent? Is how much is the variable 1 increasing? Let's consider if variable 1 is increasing. What is the effect of variable 2? Is it increasing or decreasing? Okay, or if variable 1 is decreasing, is variable 2 decreasing or increasing? So it can be shown by having this covariance. Is it clear? So initially, this is what you're going to have as a data. Next, after we are going to apply this PCA, that's principal component analysis. So what we're going to do is we're going to draw a new axis, meaning we're going to draw some new what is that? You're going to get some new features out of the data feature that you have. So initially you might have this one. So you'll be drawing one straight line that has maximum variance, that has maximum spread. Okay, here as well. And whenever we're going to draw this PCA2 as well, that will be perpendicular, that will be 90 degrees with the PC1. So if you see, the PC1 has so much of data that is spread out, right? But in case of PC2, you have only this much. Is it clear? So as and when you're going to draw this PC1 or PC2, the first PC1, the principal component axis will have maximum, and the next one will have a lesser than the first one. The third one will have lesser than the PC2. Okay, it goes on. Is it clear? So principal component analysis is very, very important. So what this is going to do is, it is going to first, whatever the data that you have, first it is going to draw a, what is it? It will be scattered in your plot. Next, it will be able to draw some linear, what is it? Linear graph or a linear line. Okay. So how does it draw? It is going to draw the line which has the maximum variance, meaning which has the maximum spread out in our data. Okay, now PCs capture the maximum variance in the data. That is what I was talking about. So what does it do? It is going to capture, it is going to collect which has which wave factor or which feature has the maximum variance. Okay, so we are talking about PC1 captures the most variance and the next one captures the second most. Is it clear? So this is very, very important. So this is also a dimensional direction itself. So what we're going to do, you're going to literally have a new axis. You're going to have a new feature, okay, that has more impact. That more impact is nothing but this maximum variance in the data. Is it clear? So to summarize the whole this unsupervised learning is, so we are going to discover the patterns without any explicit labels, meaning what, you will not be having any kind of targets or outputs. Is it clear? So clustering means grouping similar data points, isn't it? That is what we have done with the k-means clustering, right? Next we have this dimensional deduction. So what is a dimensional deduction? It is to have only those features that has most impact, meaning what, you're not going to get out the importance of that data. You're going to contain the important data in your data in your data set. By having that itself, you'll not be spending much time on the irrelevant or the inconsistent data that you have. Is it clear? Yes, guys, is it clear? I go fast. Protein intake as well. Is clear about unsupervised learning? And did you guys practice this k-means supervising learning at your home? Yes. So I'll do one thing. I'll be sharing the quiz. So please, I'll be sharing a link. Okay. So please attempt this. Just give me a moment, as this has to be shared by today's class. The link is yet to be shared. Just a moment. But before that, yes, Nancy, I think I forgot to share you this. Just a moment. Let me share you the self-paced courses. Guys, please go ahead with the self-paced course. I want to share this link. Okay, please have this and then enroll for this IBM and then complete the self-paced course. Okay, this will have some clarity on how this ChatGPT LLMs work. Okay, we have GPT models and all, right? Generative pre-trained transformers and also DeepSeek we have. So I've set this, given this. So please make sure you're going to complete this by next class. Excuse me, guys. Hello. So with that said, hope everyone are able to access the link, right? Can you please confirm me in the chat Q&A? Okay, cool. Hope it's clear, right, about unsupervised learning? Yes, what should this? This is like a self-paced code. This is not the end. This is just the one code that you have to complete it. Okay. To first create a what is that IBM ID. So create that with your personal email address or any of the email address. It would I would suggest you to go on with your personal email address itself. Okay. So with that said, let me take the next concept as optimizing your model that you have. So yes, guys, hope my screen is visible to all. Can you please confirm? This doesn't take more than I think 1 or 2 hours to complete. I'm not sure with the time. Yes, guys, any idea? So now we are going to optimize your models. Meaning what? Fine tuning. मतलब आप तो ट्रेनिंग कर लिया है, बाद में evaluate भी कर लिया, बाद में like once you've done your evaluation, now you want to go back and then change some parameters. Okay, or you want, let's consider a real life example. We can take an example of you baking a cake. Okay, so when you're going to bake a cake, the ingredients can be your eggs, sugar, and then flour, right? Flour. So these can be considered as your data. Okay, but what do we going to do in this optimizing your models is nothing but hyperparameter tuning. So what are the hyperparameter tuning is? Initially you would have trained your model, okay, but after some what do you say training, you will not be seeing your model performing well. Okay, now you want to go back and then improve the performance, meaning improve to give your model a good amount of accuracy. Okay, in that case, what you have to do, you have to go back, change your consider error, and then make all the changes so that you will not have what is that bad accuracy. Is clear? So as I took an example of what was that? Yeah, baking a cake. So what are you going to do? So hyperparameter tuning is nothing but you're going to set your parameters at the start itself. Okay, up training ke pehle hi you will be specifying. So these are the parameters, these are the values that I'm going to consider. Be it for the number of decision trees that I can consider, or sorry, number of depth or the number of levels that I can go for. In case of decision tree, or number of clusters that I can consider for k-means. Okay, so in case of baking a cake, so what हम क्या समझ लेते हैं मतलब you can consider data as like your flour, sugar, and eggs. Okay, these are your data. Okay, your model will learn to what is that, identify some patterns. Okay, now but before that, what you're going to do is you have to make sure what is the temperature that you're going to give for oven. Okay, and what is the baking time, and what is the baking powder, or like how much are you going to add 2 tablespoons of baking powder or 3 spoons of baking powder. So this will be known to you, or this will be set in the prior itself, right? Isn't it? So the oven temperature and all, or are you going to test it when you're going to cook it? You're going to bake it? No, right? This will be, how will you be, let's consider for your oven temperature, you will be having, what do you say, 350 Fahrenheit or like 180, what is that? Centigrade. Okay, so this is the temperature that you can consider, or for baking time, we'd consider 30 minutes, isn't it? So this is your rough guess that you're going to consider at the start itself, isn't it? So that is what I want to do in this case of hyperparameters tuning as well. So what are you going to do? Like in case of if your oven temperature is very low, okay, आपका ओवन का टेम्परेचर ज्यादा लो रख दिया है, तब क्या होगा? आपका बेकिंग कुक लाइक आपका केक कुक होगा क्या? नहीं होगा ना. और if you're going to have your temperature high, so what it will do? It will going to burn inside itself, isn't it? So to not have all these kind of thing, meaning what? To not have your model performing not good, what you will be doing is you will be setting some parameters values at the start itself. Is it clear? So why do we have to do that? It is to improve your accuracy in your model. Okay, is it clear? Or we can take an example of, let's consider everybody would have definitely had a bicycle, right? Isn't it? And if you're going to go up a hill, okay, if you're going to go up a hill, you're definitely going to go for a lower gear, right? Isn't it? So why do we have to go for a lower gear? Because it is going to make your life easy, isn't it? It does apply the same thing. Or if you're going to go for a flat road, so what you're going to do? You're going to go choose a higher gear, isn't it? That is for speed. Is it clear? So here as well, you're going to choose the hyperparameters. So hyperparameters are nothing but you're going to set some values for the parameters at the start itself. Okay. So by having this itself, you will be having your model running perfectly without having any kind of issues. Is it clear? So you can have this hyperparameter tuning like you're finding the perfect gear. Either it can be a higher gear or lower gear, depending on the model, isn't it? So here as well, we might consider the learning rate. Okay, so meaning how much is the our model learning, like step by step. Okay, next we have the number of trees in case of trees, and in case of batch size also we can consider, like in each batch how much are you going to. So in each, so you might have like 100 samples. So inside these 100 samples, what is the batch size that you're going to consider? So is it 50 or is it 100 one shot or is it 200 one shot? So depending on that, you'll be choosing the batch size. Is it clear? So these are all what? These are nothing but the parameters that you can consider. Excuse me. Done. Okay. Now, examples that you can consider. Is it clear, guys? So hyperparameters are nothing but it is not learned. Okay, learn कब होता है? When you're given some training, right? So a hyperparameter तो पहले ही हम डेटा को वैल्यू दे देते हैं. Okay, parameters के लिए. So here you can consider parameters as like for in case of k nearest neighbors, you'll be choosing how many k values that you're going to consider, how many neighbors. Next, in case of decision tree, how much depth, meaning what, how much level you're going to go. Okay, and in case of random forest as well, so random forest is nothing but it's a collection of, you can consider multiple decision trees. Is it clear? So depending on these parameters, you will be able to guess, like you will be able to have some conclusion about your performance in your model. Is it clear? So make sure parameters are set by us itself. It is like we giving it, right? Can I share how do we matching this with the yes, I'm going to share the content, guys. Don't worry. I'm doing it right. Did you guys check in the Google Drive? So this can be talked at the end of the class, okay, regarding the content and all. So is it clear about this hyperparameter tuning? Why do we need that? So initially you will be training your model and it would not be giving you what is that good amount of accuracy. So to have this, what you will be doing is you will be literally having some parameters defined at the start itself. Just like you're going to choose the right temperature for you to bake a cake. Okay, isn't it? Or the baking time, or the baking powder, what is that? Quantity at the start itself, isn't it? By considering this itself, you will be able to bake your cake, isn't it? So these are nothing but these are not learned during the training. These are all fixed at the start itself. It is by us itself. Is it clear? I hope it's clear, right? Now, let's go to the next slide. So, why do we have to tune the site parameters? It is to define the settings that are really optimal for your specific data. Next. So, by default, you will be what is that? Giving some values for your parameters. Okay. So, depending on the model that you're going to choose, you will choose your respective parameters value. Okay, why do we have to do that? It is to optimize, it is to improve the accuracy, or what is that, optimize your training model. Is it clear? So what are the things that you're going to consider by having this hyperparameters tuning? You will be increasing the model accuracy, precision, and other metrics. Okay, and most importantly, guys, it is going to prevent the overfitting and then our what is it, underfitting. So what is this overfitting? Overfitting is it is nothing but you're going to at the training itself you will be analyzing, or you will be finding patterns from the minute data. आपको कितना छोटा-छोटा data रहता है ना, उसको सभी it has learned so much. Okay, is it clear? But it is not able to put it into for training data. You can consider an example of, let's consider you for an examination. You might have for some one examination you would have prepared. Okay, for that particular subject, but you might for that particular examination you would have what is it, studied and memorized all the concepts. Okay, if you're given the same topic in for the same examination, you will be able to answer it, right? But if you're given out of surprise, okay, surprise के लिए surprise करके एक और एक एग्जाम देते हैं, then if you're not even able to collect or recollect the data, okay, from whatever you have learned or whatever you have stored, whatever you have memorized, it will, that is the concept comes under this overfitting. Okay, so what does this underfitting, sorry, overfit, what does this underfitting represent? Underfitting मतलब आप इनिशियल में ट्रेनिंग में कुछ ही नहीं सीखा है. ओके, सो ट्रेनिंग में कुछ नहीं सीखा मतलब will you be able to do it in your exam or in any kind of game? No, right? Is it clear? So it does also helps in what is it, overfitting and then underfitting. Next, we have this grid search method. Okay, what are the method that you can tune? For the time is 3:10. Okay. Yes, guys, I think you can take a break. It's fine. I started the quiz class at 2:10 itself. We can take a break. Yes, guys, take a break for 5 to 10 minutes, and then we will be right back. Then complete this hyperparameter tuning, and then we'll finish off with our quiz. Okay. Next, if possible, we're going to do some coding regarding this random forest and all these things in the next class. Make sure you're going to attend tomorrow's class well, because maximum tomorrow will not be having any AMA session, but I'm trying to have the backup of yesterday's class. Okay. Yes, the link that I shared is for the self-paced course that you have to do it. I hope it's clear, guys. So take a break, then we'll be right back after 10 minutes, right? 10 to 15 minutes. Yes, guys, can we resume the class? The first link that I shared is for you to complete the self-paced course. Okay, here you will be having video. What is it? Encrypted. What is it? Video. Guys, they will be explaining the concept. Then you also have this transcript as well for that video. So please follow that and then go through that whole course. Okay. So once you're done with that, you will be having, I guess, you'll be having some questions to answer. So once you're going to answer that, you will be getting badge or any kind of small certificates. Okay. Now, let me share my screen. Yes. So we are done with this hyperparameter tuning and all, right? Yeah. Now we have this grid search. So any idea about what is this grid search is about? This guys, grid. What do you understand by this term grid? So we have learned about what is this hypertuning and all. Why do we need to have that and all, right? Now we have this one thing called as grid search, right? So initially you have to mention your parameters, right? Parameter values. So to consider these parameter values, there are two things. One is grid search method and the other one is randomized search. Okay. So the first one is grid search method. Okay. So it is like, let's consider, to make you understand this, we can take an example of, let's consider you have got a new TV to your home. Okay. In your home, you have got a new TV. Okay. In this, meaning first we have to understand we are going to have this hyperparameter tuning, meaning where we will be assigning a value for each of our parameters. Okay, parameters can be number of depths, the length of the depth, the number of decision trees, right, the learning rate, everything, these things. Okay, so in these things, what are the values that we have to consider? Okay, depends on two things. One is grid search method and the other one is randomized search. So here, coming to the first one, that is grid search, we can take an example of I was taking an example of, yeah, let's consider you bought a new TV to your home. Okay, now at the start itself you want to find the perfect picture settings. Okay, आपको TV लेने के बाद you want to find which is the perfect picture setting that you want to have for your TV. Okay, so let's consider you have two things. Okay, one is to looking for the brightness and the other one is for the color. Okay, so in case of brightness you can consider the features as high, medium and then low. Okay, these are the values for the parameters. Okay, so in case of color, you can consider warm, normal, and then cool. Okay, so these are the two things that you have, right? So these are nothing but the values for the parameters that you have. Is it clear? So in these parameters, values, that is low, medium, high in case of brightness, and cool, normal, warm in case of color. Okay, so what are the combination that you can consider? Okay, so that you will have the best perfect picture settings. Okay, so in this case, in case of grid search, what we will be doing is we will be having all these things put it into some kind of grid. Grid is nothing but you can consider a matrix, okay, or a box you can consider. Okay, in this, what I'm going to do is you're going to go and then use each value in your training model. Okay, meaning let's consider for the first one, you might consider for brightness, you might consider low, and for color, you might consider cool. Next parameter value that you can consider is brightness is low, color is normal. The next, the brightness is low, the color is warm. So in this case, what are you trying to see? You're trying to use all the data points that you have. all the value that you have mentioned for your parameters. So in this way, what are you trying to see? You're trying to see the most, what is that, have your parameters value trained for all, for your model. Okay, इसमें क्या अच्छा लगता है उसको हम लेते हैं ना. So इसी तरफ से हमारा हाइपर पैरामीटर ट्यूनिंग में भी क्या कर सकते हैं, मतलब like for setting the brightness low, what you want to choose, you might choose the brightness is low and colorless is cool, isn't it? So in this case, you will be trying out with all the data points that you have, not any random thing, starting from each value till the end. Okay, you will be having combination of these values all the time, okay, every time, so that each value will be used at once. Okay, so in this case, what we're going to do is we're going to literally, or you can take an example of what do you say, जब ऐसे होता है, like if you're going to consider all the values, okay, if you have less number of values, let's consider here we have for brightness we have 3 values and for color we have 3 values. But what in case if you have hundreds of values for each parameter? In that case, what will you do? You have to consider for each values, right? So each value individual क्या क्या value है उसको सभी parameter value लेके you have to train it, isn't it? So इसे करने से हम क्या होता है, इसे करने से हमको ट्रेनिंग ज्यादा टाइम लगता है. Okay, you might not be able to get the accurate answer. So in that case, what you will do, it is better to not choose this. So then comes the usage of randomized grid search. Okay, so in case of grid search, it is like let's consider you have a home. Okay, now you want to open a single door. Okay, to want to open a single door, let's consider you have a bunch of keys, and bunch of keys might have 25 keys. Okay, to check for the right one, okay, for that particular door, you have to test it with all the 25 keys, right? In a similar way, in case of grid search as well. So what are we going to do? We're going to try out with all the value that we are going to have, okay, and find the majority one, okay, for our model. Is it clear? So if you have a parameters which are less, okay, which has less values, okay, then for each parameter you have a less number of values, then you can consider this grid search. Okay, but in case of if you have more number of, what do you say, in case of more number of values for each parameter we have, then comes the randomized search. So what are these randomized search? It is like rather than having, so initially we took an example of this one, right? Baking a cake. So in case of baking a cake, we were what did we do? We were trying to, what were we trying to do? So initially we were trying to have a temperature at either it can be 375 Fahrenheit or 300, 350. Let's consider you're trying to bake your cake with the oven temperature around 300, 325, 350, and then 375. Okay, these are all the lists that you have. These are the number of values for the temperature for the oven, isn't it? Now, this is what you're going to consider for grid search, meaning you will be taking all these values and then finding the performance. How is your model performing? Okay, but if you're going to go for the randomized search, what you can do, you might not go for each value, okay, but you will be giving a given range. Okay, A range that A range. Okay, let's consider for grid search. What did you consider? You might consider, you would have considered from 300, 325, 350, 75, 375, right? So instead of that, what you can consider is you can consider range from 300 to 375. Okay, so what this will do, this will not, meaning it will not go for each values, but randomly it might take and give you the best one. Is it clear? That is what is going to happen in a randomized search method. Okay, so to give you the if you have, the only reason for using this randomized search method is if you have values for each parameter. Okay, and for each parameter if you have values more than 10 or 20, then you can consider this randomized search method. Okay, so here what you will be doing, you will be literally choosing a random feature, okay, a random value. By if you're going to do that, you're going to select the one that performs best very well. Okay, here you're not going to spend much time on your training part, on model training. Okay, or we can also take an example of, let's consider Pratik has planned to open a new coffee shop in a big city. Let's consider Mumbai. Okay, so if he wants to set up a new coffee shop office in Mumbai, so what he will do, he has one option. Okay, so what is one option? He will go try every single building. Okay, every building में जाके और rent कितना है, फिर traffic कितना रहता है. Okay, or he might choose multiple other things, right? You have this one option. What is going to every single building and then getting inquiry. Yes or no? You inquiring about the data for your new coffee shop. Okay. What is the last one? The last one is nothing but you're going to choose the 50 different locations across the city. Okay. आपको 50 different locations में जाते क्या कर सकते हैं? This may you directly go to that particular location and then find a particular building. If it is working, you're going to choose that. Is it clear? So instead of going to each building in that city, you can choose the 50 buildings that does have a lot of impacts. Is it clear? So you're going to randomly go and then choose a particular building rather than going to each building and then completing one city, completing one particular place, meaning completing one particular location, then going to another location, going to the each building. That comes under when we have the random grid search method. But in case of randomized search, you're going to have randomly 50 locations. You directly go and then check the performance. Is it clear? So that is the difference between both of these grid search method and present a randomized search. Okay, so to make you understand more simple, what we can do is we can take an example of we can go to the next slide. So what does the next slide shows? So it shows that in case of grid search method, so what you will have your data points. Okay, so in this data points you will be having these point. Okay, this whatever you have this point, right? You will be having a combination of this Z and then A and then finding it. Once this is done, you will be finding this metric. You will be finding this parameter value. Then you will be finding the model performance. How is the training? Then you're going to choose this one. So it is going to go for each point. Okay, you're going to go for each point and then check the performance of the model. Is it clear? But in case of randomized, what it does, it is scattered in different places, right? So what this will do, it's going to go and then find the performance. If it is good, it is going to take it. Okay, or if it is not good, it is going to choose another one. Okay, so by default, what is it going to do is it is going to, in case of we have this average method, right? So this whatever the value that gives a maximum accuracy, you're going to choose that, or the majority one that is going to provide that, you're going to choose the respective one, isn't it? That is what we were done in classification K-means means method, right? So you're going to choose the majority one for the respective cluster and average for the numerical value for the regression kind of problems, isn't it? So that is also a similar way of finding this grid search method. So here you have to understand that if you have less number of values for each parameter, you can consider for this grid search method. Okay, as you will be able to find your performance of the model. Next, in case of randomized search, you will be giving a range. Okay, आप पहले ही range set करने के बाद you will be finding different combinations. Okay, out of these combinations, what you will do, you will find the one that best performance, that best performed your model. That's clear. Next, we have this ensemble method. So what is this ensemble method? Ensemble method is nothing but instead of considering one model, okay, for a data, it is better to consider more than one models. Is it clear? So to make you understand this more simply, we can take an example. Let's consider anybody would have yeah, you would have definitely college, you would have definitely joined your college based on some or the other of your friends. Assessment course. We're going to talk about that later, guys. So where was I? Yeah, ensemble method. So let's consider you would have definitely joined your college not by one person's opinion, right? You would have considered multiple friends of yours opinion, and then based on that answer, you will be joining your college, right? Isn't it? So similarly, what we will be doing is, let's consider it is similar to your college, or let's consider you want to buy a new mobile phone. Okay, so will you directly consider your one friend's suggestion, or will you going to consider multiple friends' advices and suggestion? Based on that, you'll be able to take up a call. It's better to consider multiple people's opinions and then suggestions and then take up a call, right? In a similar way, what we will do is we you want to have this ensemble method, what we're going to do is we're going to include more than one models, multiple models. Okay, so by having this multiple models, you will be able to give a clarity. You will be able to analyze the data, or you will be able to predict on the data that you are going to train. Is it clear? So what are we going to do it in our ensemble method? We are going to use multiple models instead of one. Meaning what? Rather than considering one particular model, you're going to consider multiple models. Why do we have to have that? It is to have a good accuracy for your data. Okay, not only accuracy, you have precision as well, right? So if you want to have that, you're going to use this ensemble method. So what is this ensemble method is? It is to have multiple models, okay, instead of having one. Okay, now what are the why do we have to have that? So the reason for having this ensemble method is it is to increase the performance of your model. Okay, that is to increase your accuracy. Next comes the robustness. So what is this robustness? So since you have considered multiple models, right? If you have issue with the one model, let's consider one of your friend might give you a negative suggestion. Okay, while let's consider you have 10 friends, and among those you have among those 10, one friend might give you a negative suggestion, while the others can give you 9 good suggestions. So which will you going to consider? You're going to consider the 9 people's suggestion, right? So it is the same way in case of here as well. So what it is going to do? It is going to be less sensitive to the noise. So it doesn't care much about the noise. It only cares about the good quality data that it has. Okay, and moreover, it is more reliable on the unseen data. Meaning what? Whatever the data that you're going to have, since you will be using multiple models to train your data, right? Just because of you having this, you will be able to get or take a decision or predict a particular value or predict a particular class or predict a particular cluster, depending be it any kind of new data that you have. Is it clear? So it also reduces the single model making a big mistake. What is that? That is what I was talking about, right? If you have one friend who gives a negative suggestion, it is better to remove that, since you have 9 more friends who have given a positive response. Is it clear? So there are 2 things. One is bagging, and the other one is boosting. So what is bagging? So bagging is nothing but the abbreviation for bootstrap aggregating. So what is it? Bootstrap aggregating? Bootstrap aggregating is nothing but training your models independently. Independently, matlab one model will not be depending on the other one. Okay, on different subsets of data. Meaning what? Let's consider 100 data samples. So in this 100 samples, 20 will be training on one particular model. The other 20 will be training on the other type of model. So in this way, what are you trying to see? Training your data, okay, which is not affecting the other model. Okay, so here what I'm trying to see, finally you're going to choose the most for average, for which is the accuracy. Okay, you're going to find the average value, or if you're going to choose a model which has maximum number of majority vote, you're going to consider that model. Is it clear? Now we can take an example of to understand this bagging. We can take an example of, let's consider you have a what is that coach, okay, sports coach. So he will be not only coaching you, okay, he will be coaching in multiple teams. Okay, and multiple teams matlab ek team ko or dusra team ko, they will not even have any kind of interaction. Okay, meaning whatever the performance of one team will not be known or will not affect the performance of the other team. Okay, so what this is coach will do, he acts like a bagging. Okay, so what he's going to do, he's going to prepare multiple independent teams. Okay, so meaning what, each team will have their own strategies, each team will have their own set of players, right? So depending on that, you will be training your data. Okay, and why do we have to have that? To have this independency, meaning you do not have any kind of dependency, meaning whatever you do in one type of data or whatever you do in one type of team will not completely be on its own itself. Okay, now why do we have to have that? So we're going to have that in case of if you're going to choose the majority vote. So what does it do? Like one final day, initially you will be training on multiple independent teams. Okay, and one final day सरप्राइज बोल के एक टीम और अपोनेंट आएगा, उसके पास उनके ऊपर हम खेलना है. So the team which plays very well, Okay, the team which plays very well is going to be considered for the final show, right? Isn't it? So that is what we're going to do in this bagging. So what is going to do? We're going to find the majority vote and average for your precision or predictions. Is it clear, guys? Now, in case of we have this boosting as well, right? So what is this boosting? Boosting is nothing but let's consider the sports itself. So initially, yeah, I am the coach, right? So whatever the new player, okay, let's consider player one. Okay, whatever he will be training, okay, he will be given training and he will be checked his performance. So whatever the mistake that he has done, okay, the second player, whoever comes the next, he will be looking at correcting the mistakes of the first player. Okay, next, what is the third player? Let's consider the third player. It's nothing but the third model that we can consider. So what this third player is going to do is going to consider checking the mistakes done by the player 2 or the model 2 that you can consider. So this will be done in a sequential manner. Okay, but in case of bagging, what you will do, you will be training your model independently, and finally, which is the one that is performing best, that will be chosen. Okay, but in case of boosting, what you will do, you will be training your model one next to the other, meaning you will be training one model 1, and whatever the mistake that has been gotten from model 1, that will be solved from model 2. Okay, and this will also be trained. Next, whatever the mistakes that has been traveled from done by model 2 will be solved by the model 3. Is it clear? So meaning, what are the mistakes or what are the weakness of model 1, it will be solved from the next model. Is it clear? So that is what this bagging and then boosting. And bagging and boosting is very, very important. So training multiple models independently on different subsets of your training data. Next, we have this boosting. So what is this boosting? We are going to train your model sequentially. Meaning what? Sequentially matlab one next to each other. So next to each other matlab kya? So what are the mistakes or what are the errors that has been done from the first model? It will be learned on the second model. Is it clear? So this is bagging. So what is this bagging? So you'll be training on multiple models independently, and each model learns from the random subset of your training data. So here with replacement, मतलब क्या? आपका subset में data रहता है. पहले आपका universal set रहता है. बाद में you will be splitting into multiple subsets, and each of these multiple subsets will be trained on multiple independent models. Okay. So once it is done for having this predictions, for majority vote, for classification, that is what we did in K-means, right? And in case of regression, we're going to consider the average value. Okay, and this bagging is mainly used to solve the problem of overfitting. And an example for bagging is a random forest. So what is a random forest? Random forest is nothing but into a collection of multiple decision trees that you can consider. Okay, you have decision tree, just like you have a forest is nothing but a collection of trees and plants and everything, right? So random forest is also the same. It is a collection of decision trees. And when comes to bagging, so what are we going to do? We're going to consider multiple decision trees. So small trees that can be considered and then train. And in case of classification, we're going to find the majority vote, whichever is performed well, the more we can consider. And for regression, we're going to consider the average value. Okay. This is what I was talking about. Initially, you have a universal set, then that will be split into 3 different subsets, and this will be this first subset will be trained on one model. The second subset will be trained on second model. The third subset will be trained on the third model. So once this is done, so whichever you want to do this aggregation. Okay. So what is aggregation? Depending on the use case. If it is a classification, you're going to choose the majority one, and if it's the regression, you're going to choose the yes. Is it clear? So data is nothing but this bag is nothing but you're going to have each model trained independently, and in case of classification, you're going to find the majority mode, and in case of we have this regression where we're going to find the average. Okay. Next, we have this boosting. So what does this boosting represents? Boostings are nothing but you're going to literally have your models run sequentially, one after the other. Meaning one after the other means, so initially you will be training a model. Okay, so whatever you have learned, Okay, this should not be whatever error that it has come, it should not be followed with the next model as well. So to solve this, what is going to do? You're going to solve the errors that has got from the previous one. So what I'm trying to see, you're trying to learn new stuffs. Okay. So the example for this boosting technique is we have add a boost and then XGBoost. Clear? The time. Okay, 15:10. I hope it's clear, my guys. So it is about ensemble is very method. Ensemble is method is mainly importance is you want to consider multiple models to have a what is it? Good trained model. Okay, to optimize your model, you're going to consider this ensemble method. So in this we have bagging and then boosting. So bagging is nothing but you're going to choose to train your multiple models on different subset of your data independently, and depending on the classification and regression, you want to choose the average for regression and majority mode for classification. And coming to boosting, boosting is nothing but it is also kind of ensembling method itself, where you're going to consider multiple training models. Okay, so here, whatever that first training model that you have trained, what are the mistakes or what are the errors that it has got, it will be learned from the next model. So it sequentially goes. Is it clear? So finally, what you will have a good model that doesn't have any like least error. Is it clear? I think it's clear, right? Now to understand this in a pictorial form, this is what is boosting is. So initially you'll be having your data, okay? Then you'll be using a model, okay? The read classifier, meaning what? There's the first model, okay? Then you'll be using whatever you have learned, that you will be training on this data itself, okay? So in this, what are you trying to see? The first model you have learned, you are finding some errors, okay? Or you are finding some mistakes. Now you're going to go back and then change those. That's clear. So in case of boosting, you are having multiple models, but in case of this one, you will be training on the same bit of data, okay, same data set, but here you will be having the models. So what are the mistakes that has been made from the previous model? It will be learned. Is it clear? And random forest is very important. So what is this random forest? Random forest is nothing but it is a sequence of decision trees. So these decision trees will be trained on random data set. Okay, random subset meaning what? You might have 100 data samples or 1000 data samples. So these data samples will be split into multiple batches and will be trained on multiple decision trees. Okay, so it is very important for both classification and as well as regression as well. And the main important of using this random forest is this it is going to reduce your overfitting. ओके, सो आपको पहले एक ही डेसिशन ट्री है, उसमें ज्यादा ओवरफिटिंग आएगा. ओके, डू नॉट हैव दैट. व्हाट यू कैन कंसीडर, यू कैन हैव मल्टीपल डेसिशन ट्रीज. ओके, बाय हैविंग दिस व्हाट यू आर लिटरली ऑप्टिमाइजिंग योर मॉडल. इज इट क्लियर? So just give me a moment. I'll share the link. It will be in the form, okay? So please answer accordingly. Yes, guys, I have shared the quiz form. Okay, so please do attend it and then confirm your answer is done. Everyone able to access this form? Confirm me. Yes, guys, please do attend this quiz and then confirm me once it is done. So tomorrow we'll have some coding, and I'll also give some introduction on deep learning as well. Okay. What is the hall ticket number? You can mention your register number if possible. Mention your register number. So it is a quiz. Whatever I did right, it is from my end to check your knowledge. So whatever the form that I have shared, it is to get some clarity on from our team. Okay. And once it is done, just do let me know. Don't worry about that. So whatever the form that I have shared now, please make sure you have a impact. Okay. Please do this quiz clearly. Okay. Okay. How was the quiz? Was it easy? Was it hard? Was it medium level? Easy. Okay. Okay. Make sure, guys. So if you're not able to remember the technical terms, just try to relate with the some real life examples. Okay. So if you're able to do that, it's more than enough. So please do have your present in tomorrow's session as well. Try to give some introduction about deep learning and is it clear, guys? So until now, whatever you have left us, so we started off with Python, right? And in Python itself, we learned about the data types, function, loops, conditional statements, functions. Then we started off with libraries, pandas, numpy, and then matplotlib. And then what did we do? We started off with machine learning concepts. So in machine learning also, we also did about ED as well. That is exploratory data analysis, isn't it? So in that we learned about how to pre-process your data first, explore what is the data about. Then if you're finding any kind of missing values or repeated values, you are using so much of imputations and all, right? And we also have this one hot encoding where you're going to convert your categorical or text data into what is it, computer understandable data in terms of numbers, like, isn't it? Now after that we learned about supervised learning, what is classification and regression. So this week we learned about what is the classification, what are the different algorithms. We also ended up with coding as well, right? And coming to this regression as well. It was taught in the previous week, but I did give some introduction about this regression in the last class. And I started off with, after that we started off with this one, right? What did we? Yeah, we started off with unsupervised learning. So in unsupervised learning, we learned about clustering technique, and we learned about k-means clustering. And in today's class, we learned about the remaining dimensional reduction, hierarchical clustering, PCA, and so, and what about we have learned now, that is hyperparameter tuning. So it is to optimize your trained model. Is it clear? I hope it's clear, right? Yeah, tomorrow will be a doubt clearing session, but I hope you will not have much doubts. If you have, you can just inquire it. And if possible, I'll start off with deep learning. Okay. Although I'm not having much time to do about the code, what I'll do is I'll try to create my own notebook and then share it to you. Okay, because trading takes, me coding the live would take a lot of time. But what I'll do is I'll share the IPynb file in our drive that you can have a glimpse at it, and then you can start doing it. Okay. Hall ticket number you can have. You don't have to mention. You can just mention your random numbers or your registration number in your college. Yes, Dhiruvalankushi, raised. Yes, guys. Once you confirm, we can end the session. Channel, have a good day, have a good weekend. Until Monday. Yes, guys, if you're having any doubts, I'm here about 5 more minutes. You can clarify your doubts. Please do make sure you attend the tomorrow session as well. Okay, thank you so much, guys. I will meet you in the next session. Okay. Then you can leave the session. Having any kind of doubts, you can mention. Yes, Monica, we don't have any WhatsApp group, but we have a Telegram group. Okay. Now, Akanksha, what you have to do is click on that link, create an IBM ID, okay, with the Google account. Then there will be a self-paced course where you have to complete that. Okay. So that will be about introduction to large language models. So once you're going to get into it, we'll have a video, okay, where they will be explaining about this concept. And also, once you're going to finish that, you'll also have this transcribe as well of that whole video. And finally, you have to attend a quiz. So after attending it, you'll be getting a badge or any kind of certificate. This has to be done. So please make sure you have this personal email address given, or whatever the mail that you have given for this program, right? Experiential learning, give the same as well. Yesterday, we didn't have any kind of session. Krisha? Snehal, when will we get a training certificate? So just make a note, first 40 hours to 45 hours of instructor-led training will be done. Next, you will have to complete all the self-paced courses that we're going to send. And finally, you have to do your project. Okay, so project, yes, all this project document, what is that project and all will be done after this training. Okay, after instructor-led training is done, right? Then you have to go on with your project. So where you will be getting a project, what are the things that you will be doing, will be known to you, will be told after this, after the 2 weeks. Okay, so we have our platform called as Skill Wallet. So that Skill Wallet, you will be accessing your project. Okay, so whatever the update that you're going to do, if you're done with the data collection, you have to come and then update it. And likewise for all the steps. Is it clear? So to get the certification, you have to do 3 things. One is self-paced courses. Second is complete the project. Then after complete the project, you have to make a demo video of your whole project. About 5 to 10 minutes. This 3 things, and finally the last one is project documentation. So if you're going to consider all these things, then only you will be given the certifications from our team. Okay. So how to submit the project and all will be known to you in the project mentoring session. Okay. What is the self-paced learning is? We will not be teaching anything, but we will be giving a course link. Okay, so that course has to be finished by you. So given your time, given your spare time or your free time, you have to go and then go through all the videos, and finally you will be finish that whole video course by attempting a particular quiz. Okay, so once you're going to attempt the quiz and then gets the required marks, it will be more than 80% or 70% of the total marks. Once you get that, you will be getting a badge or a certificate. Okay, so this is सेल्फ बेस्ड मीनिंग आपका टाइम कब जाता है आप पढ़ सकते हैं पढ़ के आप क्विज का फिनिश करके यू विल बी गेटिंग द बैच. Yeah, it is not that mandatory you have to complete it now, but given in about next week, try to complete it. Okay. Sir, can you share the tutorial that how to do activity in this, which is in the last of every lesson in this link? I didn't get your question. You want to have the recorded session, you meaning? Want to have the recorded session? Tutorial that how to do activity. What type of activity? I didn't get it. So what I would suggest is rather than getting into full-time job and all, it is to better go for internships. As I think you will be in your second year or third year, so try to go for internships, and that too some kind of paid internships or in no internship or no stipend, because that is where you're going to learn a lot. In MNCs and all, you will not be learning a lot, but once you have got into the MNCs, so you'll be trained for about 2 to 3 months, and then you will be doing that only that particular task. But in case of MNC, like in startups and all, middle scale startups and all, you will be literally getting to learn new skills rather than only front end development and all. We will also getting exposure to marketing, developers team, operations team, everything. So it is better to try for internships. Don't directly go for full time. This is what I would suggest. Given your what is it? If you're in second year or third year. These are just the prerequisites that I have so much come after this AN and ML. Kushi, it is nothing but it will be just by clicking an IBM that link, you will be asked to register with your email address. And after you're going to register with your email address, you'll be creating an IBM ID. Okay. So with that ID, you will be able to log in and then complete that whole self-based course. Okay, it is like Udemy course that you have, right? You'll be completing self-based courses, given some activities, and then finally you'll be attempting a quiz. It is similar to this as well. Okay. Yes, whatever the quiz that I have shared now, that will be counted for your performance. Okay. Yes, guys, I hope it's clear. And let me end the session. If you have any kind of queries, you can do join tomorrow and then ask your queries. Until then, have a great day, guys. Thank you so much for joining. Bye bye. Thank you, Devendra. Thank you, everyone. Bye, guys. I'm going to end the session now. Have a great day. Bye. Sir, the last is lesson. There is an. Do you just like have the in your school days you have this match the following, right? Depending on the question which you can expect to answer, right? The similar way you want to choose this as well. Okay. Bye, guys.